Hello guys, welcome back to Byte Bloom Robotics. Today we're going to cover Newton's three laws of motion, which help us understand the foundations of classical mechanics. These laws help us understand how objects move and interact in everyday world. Let's dive into it, guys. And remember to smash that like button. Newton's first law, which is the law of inertia. Uh, Newton's first law states that any object at rest stays at rest, and any object in motion stays in motion at a constant velocity unless acted upon by an external force. Think of a soccer ball. It won't move until you kick it. This is an example of inertia keeping it at rest. And when you kick it, it keeps rolling until friction or another force stops it. This law highlights the concept of inertia, the tendency of an object to resist changes in their state of motion. Another example is playing football. Say you're running, and then you get tackled by a linebacker. The linebacker clearly has more inertia than you and has a greater outside force impacting you. This is a example of soccer where we already covered it. An object will stay in motion unless it acts by the net, and then it will stay at rest until you kick it or something else happens to it. Here we got Newton's second law, which is the law of F equals ma, where we can clearly have our variables of F is force, m is mass, and a is acceleration. And let's move on. Newton's second law establishes the relationship between force, mass, and acceleration, where it can be expressed mathematically as F equals ma, where F is a force applied, m is mass of the object, and a is acceleration, as we went over previously. For example, if you push a light object, like a shopping cart, it can accelerate really quickly. But if you try to push a heavier object, such as a loaded cart with it accelerates much slower. This law helps us explain why larger forces cause faster changes in motions and why the mass of an object affects its response. Okay. How to test your force output? Put your weight, pounds, or whatever metric you use, stone, and add your running time in the 100 meter, and you get your miles per hour from that. You can convert it through an online converter, and then your times your weight times your speed to get your force output. So here you have an example of a car, which is the same equation as representing Newton's second law. Now we can move to Newton's third law. Newton's third law means for every single opposite reaction, there's an equal and opposite reaction. Meaning, imagine jumping off a small boat. As you push down on the boat moves backwards. This is equal to the opposite reaction of your jump. This law is why rockets work. The engine pushes gases downward, and the gases pushes the rocket upward with equal force. Let's have an example. Say you punch the wall with your bare fist. The wall can get damaged. However, your hand also gets equal amount of force that you hit onto it. Example of Newton's third law, which is see you push on the force always comes back on you, the ball pushes back. So that's why the ball doesn't go far. And to conclude, the first law is inertia, the second law shows the relationship between force, mass, and acceleration, and the third law teaches us about action and reaction. Newton's three laws reveal the fundamental principles behind motion and forces in our universe. Thank you, happy for listening, and please smash that like button and subscribe.